first step, we see these parentheses, and anytime you see parentheses, you kind of think to yourself, oh, I need to use U substitution. So these parentheses are very, very important for us. So we're going to pick our U to be the quantity inside the parentheses, cosine x. Our du will then be negative sine x dx. All right, so with that u and du selected, let's see where that leads us. So we first start with replacing u to be cosine x. So this cosine x is going to get plugged in as a u. So we'll have the integral natural log of u and then tangent x dx. Now, to deal with the du is equal to negative sine x, we say to ourselves, okay, tangent needs to probably be converted to sine over cosine, and then hopefully that will allow us to get our du. So I convert tangent into sine over cosine. And then I see that I'm almost there to the du. I just need to multiply in by a negative. And if I multiply in by a negative, then I will have negative sine x dx for the du. But of course, if I multiply in by a negative, I got to multiply in by a negative on the other side of the integral to balance things out. So using my du definition, this is all going to become du. So I will have negative integral natural log of u. This becomes du. But then it still has this cosine of x in the denominator. Fortunately, though, we have the definition that cosine x is equal to u. So we can use that definition of u is equal to cosine x to replace this cosine x in the denominator with u, and then natural log of u du integrated with a negative. All right, now as I mentioned in the previous video, the way you want to work through this is you want to ask yourself, okay, do I have an integral rule for this? No, I don't. Is there a way to simplify? No, there isn't. So then I'm going to think about U substitution again. So here I want the derivative and the original function to appear as one inside of the integral. So that is going to happen by picking another U, so to speak, of W is equal to natural log of U, because then dw would be equal to 1 over u du. And what I can do is I can say that this 1 du over u, that would become my dw, and then this natural log of u, that would become w. And then we're integrating and then have a negative in front. So with that substitution, now that everything is in terms of one variable, and now we're going to try to integrate. And here, when we try to integrate, we go through the same process. We say, okay, do I have integral rules? And of course, I do have an integral rule. I have the power rule, so I can stop right there and use the power rule. So using the power rule, I will add 1 to the exponent, divide by the new exponent, then a plus c because we have no bounds, and then a negative following, tagging along throughout the whole project. So at that point, we have integrated, and after we integrate, then we substitute back. So we'll have negative. Now, my W substitution is going to go in as natural log of U quantity squared over 2 plus C. Then I make my U substitution, and U is defined as cosine x. So this will become negative parenthesis natural log. And in for that u, I will put in cosine x quantity squared over 2 plus c. And that will be our final answer.